We've covered the product rule and the theory behind it in a previous video. What I'm going to do here, I'm going to present you with a couple of questions. I want you to pause the video, have a crack at them, and then come back and check your answer against the working I'm going to show you. So here you go. 3 questions for you. First one gives you a fairly straightforward equation. You have to calculate the derivative of it. Second one ups the ante a wee bit, and then the third one shows you where we can use it, finding the equation of a tangent to a curve. Pause the video and have a ping at these. So first one, if k of x equals x squared bracket x plus 2 cubed, calculate k dashed of x. Now remember, this is the product rule, so what we do to start with is we assign our f and our g, we calculate the derivatives of it, and we plug it in the formula. So for this one, I'm going to assign the first part, the x squared, that's going to be my f of x, and the second part, the x plus 2 cubed, I'm going to assign that as my g of x. Now, I calculate my derivative, f dashed of x. So derivative of f dashed of x, well f of x is x squared, derivative of that is 2x, and the derivative of my g of x, so g dashed of x, is the derivative of this here. What that ends up giving me is 3 bracket x plus 2 squared. So what I now do is I plug it into the formula. I know that k dashed of x is going to equal f dash g plus g dashed f in our shorthand. So it's just plugging these in and then seeing what I get. So f dash g, that gives me 2x times the x plus 2 cubed, and then plus g dashed f, so that's plus 3 bracket x plus 2 squared times the f, which is x squared. Now remember, when we get one in this format here, what we try and do is take out common factors and then simplify it from there. So if I look at both terms, I can take an x out of both terms from there. So I can do that. So I can cancel the x there, and that power goes down by 1. And then what I can also take out from both terms is an x plus 2 squared. So I end up with x bracket x plus 2 squared outside the bracket. That'll go, and the power of that will reduce down to 1 as well. And then what I'm left with in our bracket here is 2 bracket x plus 2 plus 3x. So now I just simplify this final part here and then see what I get. Well, when I simplify that, what I'll end up with as a final answer is that k dashed x equals x bracket x plus 2 squared. And then simplifying this bracket here, I get 2x plus 3x, so I get 5x, and then I get 2 times 2 plus 4. So there you go. If that's what k is, there's my derivative, k dashed x. Second question now, I want to differentiate y equals x cubed sin x cos x. Now this is similar to what I explained at the end of the theory video, in that I now have 3 functions multiplied together. I can still apply the product rule, but I'm going to have to apply it a couple of times. But our general steps are still the same. I'm going to name my functions, so I'm going to call x cubed my f of x. I'm going to call sin x g of x, and I'm going to call cos x, let's name that, h of x. So if I find the derivative of each of these, so if I've got my f of x, my f dashed of x is going to equal 3x squared. My g dashed of x, so derivative of the sin x, is going to equal cos x. And then my final one, h dashed of x, is going to equal the derivative of cos x, which is minus sin x. Now, if I've got y equal to this, I know my derivative dy by dx, because I've got 3 functions there, is going to be the equivalent of f dashed gh, so derivative of f, g and h stay the same, plus f g dashed h, so in this one it's the g that's the derivative, and then the final one, f g h dashed. So it's the same 3 functions, the only difference is we're doing the derivative of a different part of it each time, and we do it until we've got the derivative of each part of the function. If I was to add in another bit here, let's say I of x, I would then have a further derivative to do, where I'd have the derivative of I. So now that we've got all this, we can just plug in what we know and see what we get at the end. So f dash gh, that gives me 3x squared sine x cos x. Then f g dash h, that gives me plus x cubed cos squared x. Now the cos squared comes from the fact that g dash is cos and the h is just cos as well, so cos squared. I've then got plus f g h dashed, so that's then going to be plus x cubed sine x, and then I've got a minus sine x there. So I've got all of that. Let's simplify it all down now. So I've got 3x squared sine x cos x. I've then got plus, now both of these terms have an x cubed in it, so let's take that out. I've got plus x cubed bracket cos squared x minus sine squared x. And that there is all sorted and simplified. Sorted the negatives here, taking out the common factors where possible. I could take it all out from here if I wanted to as well, so take an x squared out, but that then just adds more brackets, so it'll be a bracket within a bracket when I've factorised it, so we're as well just leaving it in the format it is there. Final question was find the equation of the tangent to the curve y equals x sine pi x at the point x equals a half. Now, equation of the tangent, so that would be the equation of the straight line at the curve. Remember, we want y equals mx plus c as our general form, or y minus b equals m bracket x minus a. We need that or that to get the equation. So we need to know either the y-intercept or just a point. Well, we've got the x part of a point, so from that, what I can do is I can calculate the y part to go along with this x equals a half. So what that gives me is a half times sine of pi over 2. Sine of pi by 2 is the equivalent of sine 90, which we know is 1. So it's a half times 1. So x is a half, y is also a half. So the coordinate, a half comma a half, is on that line, and I can use that for my a and my b. I then need to get the gradient. Well, remember, to get the gradient, we take the derivative, substitute in x, and see what value we get. So for the y, we know it's the product rule again. We've got two functions put together. Stick to the same method. So x we're going to call the f part. The sine pi x we're going to call g. I'm then going to look for my f dashed. Well, if f is x, f dashed is 1. And if g is equal to sine pi x, the g dashed is equal to pi times cos of pi x from that. This one here comes from the chain rule. Remember that. Go back and look at that if you need to refresh your memory of it. What I can now do is stick it all together, get my y dashed, and then substitute in the x. So what I can say is my derivative, y dashed, equals f dash g plus g dashed f. So in this case, is equal to 1 times the sine pi x. So it's just going to be equal to sine of pi x. Plus the g dashed f, well I know f is x, so it's going to be plus x times 1 g dashed, which in this case is the pi cos pi x. So it's going to be plus x times pi cos of pi x. So what I now want to do is I want to figure the gradient out at x is equal to a half. So at x equals a half, y dash, the derivative, equals sine of pi over 2 plus a half times pi times cos of pi over 2. Now, cos of pi over 2 is the equivalent of cos 90, which is 0, so that whole term there is going to equal 0. Sine of pi by 2, sine of 90, which is 1, so my y dashed, which we know is equal to our gradient, is equal to 1. So all I do is I now substitute the information into here and rearrange it into the format I want. So y minus b equals m bracket x minus a. M is 1, a and b are both a half. So I've got y minus a half equals x minus a half as well. Simplify it, add a half to both sides. It's quite simply y equals x. So that there is the equation of the tangent to that curve at the point where x is equal to a half. So we've got many applications when it comes to using the product rule. Calculating derivatives becomes a lot easier when we remember it, and we've got lots of applications of derivatives, including this kind of question here where it's tangents to the curves. There will be a lot more applications a little bit later on in the course, but we need to nail the techniques now. Make sure you nail this one down.